Hello everyone, I am Rigved and I am going to start a series on data structures and algorithm. So have you ever heard someone say that this algorithm is of order of n log n and you just agreed along? This series fixes that. This is the single most important concept in DSA and almost every channel skips it, but we are not going to. So there can be two solutions to the same task that can work but perform differently at different scales. Big is not about how fast the code runs on your machine, it's about how runtime and input grows. Because a code can work at different speeds on a computer in 1995, 2005, 2015 and today on your gaming PC. So an algorithm is a step-by-step procedure designed to solve a computational problem. Now let's see the difference between algorithm and a program. So the first difference is that algorithms are written during design phase using simple language, simple English language and mathematical notations. So we can write here that they are written during design phase using simple English and mathematical notations. And while a program requires proper programming syntax of any language we can choose. So the next difference is because our algorithm is a designing concept, it is independent of any hardware or operating systems. So we can write here and operating system, while our program it is dependent of hardware and operating system. So as we discussed that algorithms are just a designing concept, so we can write here that it is a designing concept while our program is the actual implementation of that algorithm. So now let's see how we can evaluate an algorithm and a program. So we can evaluate an algorithm with priori analysis, which means that we theoretically define time and space functions without even writing a single line of executable code. So we can write here that we define time and space functions without writing code, and we evaluate a program with the help of posteriori analysis. So posteriori analysis calculates the exact execution time in milliseconds and physical space in bytes on a hardware. So we can write here calculates the execution time in milliseconds and physical memory consumption in bytes. So now let's see characteristics of an algorithm. So first is our input. Here our algorithm must take exactly 0 or more inputs. So we can write 0 or more inputs. Now next is output. Our algorithm must give us at least one output. So we can write here at least one output, and next is definiteness, which means that our algorithm must have only one exact meaning. So we can write here only one exact meaning, no more meanings. And the fourth one is finiteness, which means that our algorithm must terminate at some point, unlike a continuous while to loop which without an exit condition. So we can write here must terminate at some point, unlike a while to loop without a exit condition. And the last one is effectiveness, which means that every step of our algorithm must be actionable and necessary, containing zero or abundant unused statements. So you can write here that every step must be actionable and necessary, while containing zero or abundant unused statements. So these were the characteristics of an algorithm, and every valid algorithm must stick to these 5 characteristics. So that was all for introduction to algorithms. From next video on, we will discuss how we can calculate the time and space complexity of any basic algorithm. Thank you.